Hey Jeff, remember a couple years ago when we were talking about why the space and satellite industry was not able to advance as fast as the computer industry did?
Yeah, I remember being in your living room and pacing back and forth, almost being angry that the pace of technology development was so slow when it came to space.
The problem was that everything happens too slow. I mean, you and I both work in the space industry of one aspect or another, and so we both have the experience of spending upwards of a decade, good portion of a decade, coming up with an idea, engineering it, developing it, building it, testing it, getting it on a launch vehicle, and getting it out into space, whereupon things fail. And if you want to fix the problems, you have to do it again.
And with a 10-year process, that means you only get 4 chances over your entire career to try a new idea.
And you have to learn from that, which means you've got to go through the whole process again.
I'm Jeff Smith.
I'm Andrew Tubiolo.
And we are Orbit Express. Everyone should have access to space. With the invention of CubeSats, satellites small enough for a small team or even an individual to build, more people than ever before can design, build, and even launch their own satellites. But because most of these people are not professional rocket scientists, their satellites fail about 60% of the time. At Orbit Express, we offer a complete package that includes satellite kits, ground-based testing, and even rocket launches, so that way anyone can be a rocket scientist. Let me introduce you to Peter. Peter's a freshman at the University of Colorado, where he's studying engineering. Peter wants to work on the next generation of GPS satellites and dreams of even someday landing a rover on the surface of Mars. Now let's fast forward to Peter's senior year. He joins his school's CubeSat program. The project is sponsored by NASA and supported by local aerospace companies like Boeing and Lockheed Martin. This is Peter's first chance to work on real space hardware. Peter is assigned to work on the radio for communications with the satellite, but during the assembly process, he improperly solders a wire. When he goes to launch his satellite, the incredible vibration of the rocket breaks the wire loose, and the radio fails. The satellite is lost. The science objectives of the satellite are not achieved. The learning objectives of the project are not achieved. No one knows what happened or why. In frustration, Peter decides to leave aerospace engineering entirely and instead decides to go make social media apps instead. Sadly, this story is not uncommon. These satellites fail 60% of the time. Each time one fails, that represents $2 million in lost effort from both NASA and the universities that built them in time, energy, and materials. This is a $100 million a year problem, and the bad news is the problem is getting worse. As CubeSats become more popular, growing at 44% per year, no one has done anything to reduce this failure rate. Peter made a mistake, but it's not his fault. It's the system that failed Peter. You see, University of Colorado is an excellent school. It produces excellent graduates. But he's taught in the same way that every other aerospace engineer is taught. His learning is siloed by class and by semester. He's never given an opportunity for hands-on learning to actually implement what he's been learning in theory in his class. Peter has to wait till his senior year to get his first real chance to work on space hardware, when the stakes could not be higher and a single mistake can ruin an entire mission. But there is a better way. We need to start in the freshman year, at the beginning, and give Peter opportunities from year to year to grow, to apply his learning, and to acquire new skills. What we're describing here is a positive feedback loop. Build, simulate, learn. As Peter goes through this process, each time he learns and adds to his skills and continues to grow as an engineer, applying what he's learned in his classes and learning lessons that can only be learned hands-on. Build. Peter will build one of Orbit Express's CubeSat kits. Each year, these kits will become progressively more difficult, applying new knowledge and giving Peter an opportunity to learn new skills. Simulate. Peter will have to go through the simulation of spaceflight environment. Yes. Peter will get to simulate the spaceflight environment, from the intense vibration of a rocket launch to the hard vacuum of space. Also, the incredible temperature shifts from going to the shadow of the Earth to direct sunlight. Finally, learn. Through these simulations, Peter's progress will be graded at every step of the way. He'll be pointed in ways that he can improve, and he'll be shown his score, so that way he can compare his own results to others, and schools and teams can compete against each other to see who can build the best satellite. Finally, the reason why you build a satellite is to be able to launch it. And Peter will be able to launch his satellite on one of Orbit Express's rockets. Now, there is competition in this field, and it has existed for some time. But generally, much like Peter's education, those efforts are siloed. Companies produce either kits or they provide launches. There is no unified approach to this. And we still see that 60% failure rate with all the efforts that go into this. Oftentimes, these companies also promise more than they can actually deliver. Our go-to-market strategy will start here in Arizona. We've been in many discussions with teachers in the state who are very interested in our product. We'll target also all of the schools in the NASA Space Grant program for Arizona. There's a NASA Space Grant program for every single one of the states. We'll move from Arizona to the Southwest region, and from there to the rest of the nation. There are currently 118 schools in the NASA CubeSat program, but that number is growing annually. We want to be in 50% of these schools in the first 5 years, which represents a $5 million opportunity. We've already assembled a great team. I've worked for a decade in such projects as ballistic missile defense. Ed Labouthier is here, and he is an author in this field and has worked on such critical safety systems as UAVs and locomotives. And then Andrew Tubiolo has worked on such Mars projects as the Mars Pathfinder rover and the Mars Phoenix lander. Going forward, we will need additional help in areas such as marketing, sales, and the design of our simulated spaceflight experience. Let's come back one more time to Peter. We remember that he became frustrated and left the aerospace industry. But now, under our program, he's had 4 years of hands-on experience where he's been able to learn from both his successes and his failures. And he's excited to enter the workforce and follow his dreams. Peter is part of a new generation of rocket scientists armed with both theory and practical experience, ready to answer some of the biggest questions in the universe and solve some of the most difficult problems right here on Earth. We are Orbit Express, and we will help you be a rocket scientist.